All right, today we're diving into one of the absolute smartest shortcuts in modern AI. It's called transfer learning. And this is a really powerful idea that's, well, it's completely changing how we build artificial intelligence. The crazy thing is, as you'll see, it's something you and I do all the time without even realizing it. Okay, so let's just start with a simple question. Imagine you've spent, I don't know, months and used a million photos to teach an AI how to spot cars. It's an expert, right? But now you need it to recognize trucks. So what do you do? Do you really have to throw all that work away and start from scratch? Well, the answer to that question gets at a massive challenge in AI development. Because you see, that question, it points to a huge hurdle in AI. Training a model from a complete blank slate, it's just a monumental task. You need massive amounts of labeled data, incredible computational power, and all of that translates directly into a ton of time and, of course, a ton of money. And that's the crucial point, right? Think about it. A chef doesn't relearn how to chop an onion for every single new recipe. So why would we make an AI start from zero for every new but related task? It just makes no sense. It's incredibly inefficient. There has to be a smarter way to use what it already knows. And of course there is. The solution is this really elegant and powerful technique that completely avoids that inefficiency by building on what's already been learned. And that technique, it's called transfer learning. So what is it? Well, to put it simply, the whole idea is about reusing knowledge. Instead of starting over from scratch, the AI takes everything it learned from one job, like identifying the general shapes of cars, and it applies that knowledge to a new but similar job, like, you guessed it, recognizing trucks. Okay, so how does this actually work in the real world? It might sound pretty complex, but the core process is, well, it's beautifully simple. Let's break it down. So it pretty much comes down to three main steps. First, you train what's called a base model on a huge general dataset. So for images, this means feeding it millions of pictures so it can learn all the fundamental stuff. Edges, shapes, textures. Second, you take that pre-trained model with all its core knowledge. And finally, you adapt it for your new task by fine-tuning it. And that just means making some small adjustments using a much, much smaller, more specific dataset. And you can see here how this process is just incredibly efficient. A model gets trained for a big primary task, right? It builds up this solid foundation of knowledge. Then you just transfer that foundation to a new problem. The brilliant part is we only need to retrain the very final decision-making part of the model with the new data. This saves a massive amount of time because, again, you're not starting from scratch. You're just tweaking the specialized bits. Now, you might be thinking this is some brand new cutting-edge idea. But what's really fascinating is that the roots of this go back decades. Yeah, decades. This is not some recent breakthrough. It's actually the result of a long, steady evolution in AI research. Look at this timeline. The first paper on this topic, it came out way back in 1976. And then throughout the 80s and 90s, researchers were developing more formal theories, really laying the groundwork for all the incredible AI advancements we see today. So yeah, this idea has truly been a long time in the making. Okay, so we've got this powerful technique with a surprisingly long history, but why does this matter to you? Why should you care? Well, because its impact is, quite literally, everywhere. It's solving real-world problems in dozens and dozens of fields. And this is where it gets really, really cool. That spam filter in your email? Yep, it probably uses a model that was pre-trained on vast amounts of text just to understand language. And then it's fine-tuned to spot junk in your inbox. Or think about medicine. Models trained on millions of random images learn to see basic shapes and textures, which then lets them be adapted super quickly to spot specific types of cancer in medical scans. From playing games to classifying brainwaves, transfer learning is the engine that makes all these powerful AI applications not just possible, but actually affordable. And hey, you don't have to just take my word for it. Back in 2016, the AI pioneer Andrew Ng made this really bold prediction. He said that transfer learning would be the next driver of commercial success. He basically saw that this ability to leverage existing knowledge instead of starting from zero every single time was going to unlock the next big wave of AI products. And you know what? He was absolutely right. But like any exciting field of science, the story doesn't just end there. The conversation is always evolving. Researchers are constantly pushing the boundaries of what we thought was possible. For example, a paper from 2020 actually found that in some situations, using a pre-trained model can hurt performance. So they suggested an alternative called self-training, where a model kind of learns from its own predictions on new data. It's just a great reminder that transfer learning isn't some magic silver bullet, right? It's one very powerful tool in an ever growing toolbox. And so that leaves us with a pretty fascinating question to think about, doesn't it? We've seen how AI can transfer skills from one task to another, a lot like we do. So as this technology gets even better and better at learning and adapting, what's the next great human skill it's going to learn from us?